Have you ever wondered why there's always someone in the comments claiming that XRP is centralized? Well, today we're going to talk about something that challenges everything most people believe about blockchain decentralization. And trust me, if you've ever been a witness to the FUD, you're going to want to stick around. The concept of decentralization in blockchain technology is wildly nuanced and frequently misunderstood. Most people think they understand it, but when we dig deeper into the technical architecture, we discover that most popular assumptions about blockchain decentralization are actually pretty backwards. Let me explain why this matters so much for the future of crypto and digital finance. You're probably familiar with people claiming that Bitcoin is the gold standard of decentralization, a supposedly democratic system in crypto. Back when I first got into Bitcoin, we were setting up small mining rigs at home, and it was very much a common hobbyist type of system where people around the world were all participating together. I thought that was pretty cool. And although there's a lot of independent crypto miners now, there are just 4 mining companies around the world that control over half of Bitcoin's network. Even more dramatic is 80% of Bitcoin mining happens in a single country that has completely outright banned crypto trading. I'll let you guess who that is so I don't get shadow banned. The concentration of power is exactly what blockchain technology was supposed to prevent. But the reality of how these systems work has led many of us down a very unexpected path. So at its core, this story is about 2 fundamentally different approaches to achieving consensus in distributed networks. First, we have proof of work, which is used by Bitcoin, formerly Ethereum, and it's used in other networks like Litecoin, Cadena, and more. The technical process here is really pretty interesting, and miners compete to solve complex math problems called hash functions. Specifically, they're looking for a value that, when combined with the block's transaction data and hashed using SHA-256 encryption, it produces a result that meets certain criteria. Typically something like having a specific number of leading zeros. This process is intentionally hard and very intensive. The difficulty of the math problem adjusts automatically every 2016 blocks in Bitcoin and ensures that new blocks are created about every 10 minutes or so, regardless of the total mining power on the network. So think about that for a minute. The system is designed to maintain a constant block time by making the puzzle more difficult as more computing power joins the network. That really kind of leads to an arms race in mining equipment, which has evolved from regular computers to specialized computers called ASICs, which stands for Application-Specific Integrated Circuits. They really serve no purpose other than mining crypto. The energy consumption implications are pretty staggering, and Bitcoin mining alone uses more electricity than a lot of countries around the world. Now, this isn't really just an environmental concern, it's a design issue that impacts decentralization. The massive energy requirements and specialized hardware needs create a higher barrier to entry and naturally leads to more centralization among those who can afford industrial-scale mining operations. Now, that's not to say there aren't plenty of alternative renewable energy sources that are being used by some, but by and large, that's not the case. In the XRP ledger, validators don't compete to solve puzzles. They instead participate in a multi-phase consensus process for each ledger version. The process begins with the consensus phase, where validators exchange proposals about which transactions to include in the next ledger. And a ledger is what you would consider a block in a proof-of-work implementation. So each validator maintains a candidate set of transactions and removes any transactions that don't receive enough support from other validators in their unique node list, or UNL. This creates a system of overlapping validator sets that together ensure the network's integrity. The overlap requirements are mathematically derived, and the network needs to maintain an 80% overlap between UNLs to maintain consistency with specific Byzantine fault tolerance calculations to determine the exact requirements for different failure scenarios. So there's currently over 180 validators worldwide that verify transactions on the XRP ledger. And as we were talking about, each validator participates in the consensus process by sharing proposals and voting with other validators. That process happens in multiple rounds, with validators adjusting their proposals based on what they receive from other validators that they trust. This continues until there's a supermajority of 80% of the validators that agree on a specific set of transactions to include in the next ledger. So let's talk about the technical advantages that this brings. First, transaction finality is achieved a whole lot faster than proof-of-work systems. And while Bitcoin requires multiple block confirmations, typically 6 takes about an hour or so to ensure transaction finality, the XRP ledger is able to get finality in seconds. This is because once a ledger is validated by the consensus process, it can't be rolled back. There's no concept of blockchain reorganization like you might see in Bitcoin. The fee structure on the XRP ledger is also pretty interesting. Unlike Bitcoin, where fees are a bidding system that miners can manipulate for profit, the XRP ledger uses a dynamic fee system called fee escalation. This system automatically adjusts fees based on the network load, but in a way that prevents validators from artificially inflating those fees for profit. The base fee starts extremely low, fractions of a cent, and only really increases when the network is genuinely congested, and not by much. The security model in achieving consensus is equally sophisticated. So, in proof-of-work systems, security is directly tied to the amount of computing power or hash rate dedicated to the network. This creates an economic incentive for mining centralization, and bigger operations are more efficient and more profitable. Whereas the XRP ledger security comes from the diversity and trustworthiness of other validators. No amount of computing power can override the consensus process, and that makes traditional 51% attacks impossible. So let's also talk about how the XRP ledger handles potential attacks. The consensus protocol is designed to be Byzantine fault tolerant, meaning it can continue operating correctly even if some of the validators are malicious or failing. Specifically, the network can tolerate up to 20% of the validators being malicious or offline while still maintaining a perfect operation system. This is mathematically proven through BFT theory and has been extensively tested in real-world conditions. Something else that's pretty interesting is how the XRP ledger handles amendments. An amendment is a protocol change that modifies how the network operates. So, in Bitcoin, miners effectively control which updates are adopted. The XRP ledger has a built-in amendment system that requires trusted validators to achieve consensus through voting. For example, if there's a proposed amendment, it must be supported by 80% of the validators for 2 weeks before it can be activated. The XRP ledger can process 1,500 transactions per second on its base configuration, compared to Bitcoin's 7 transactions per second. And this really isn't just about the raw numbers, it's about the fundamental architecture that enables its throughput. The consensus mechanism doesn't require the massive redundant computations that proof of work does, and allows for much more efficient transaction processing. When we look at the network overlay, Bitcoin's network tends to form around mining pools, and that creates natural points of centralization. The XRP ledger's network is more evenly distributed, with validators run by a big group of participants, including universities, financial institutions, and independent operators as well. That kind of diversity is really critical for maintaining true decentralization. As we start looking further into the future, the implications of the differences between these two types of systems is really pretty profound. As blockchain networks scale, the centralization pressures on proof-of-work systems are only going to increase. Mining becomes way more profitable with scale, and that leads to further consolidation. And due to the way that the XRP ledger is set up, it doesn't create those kinds of economic pressures towards centralization. In fact, the network becomes more secure and decentralized as more independent validators join. Like David Schwartz said, the best incentive is no incentive. So really looking ahead, these two different architectures are likely to influence the evolution of a lot of other systems. We're already starting to see some new consensus mechanisms emerge that try to balance some of the features of proof-of-work systems as well as those of the Byzantine fault-tolerant systems. So the lesson here really is that decentralization isn't just about having no central authority. It's about creating systems that remain truly democratic and accessible, regardless of the computing power or financial resources that someone may have. How this is going to affect global finance is pretty significant, and traditional financial systems are looking to blockchain technology for innovation, but they need something that can scale efficiently while maintaining security and remain decentralized. The technical architecture of the XRP ledger, with its rapid settlement times and low transaction cost, is particularly well suited. So maybe you've been fed a bit of a lie, and not everything is as decentralized as it appears. But some of the most surprising solutions come from rethinking the entire approach to the problem. So the XRP ledger's unique consensus mechanism is a great example of what truly decentralized systems can look like in the future. Systems that prioritize efficiency, accessibility, and genuine decentralization over just raw computing power. The future is decentralized, and I'm really glad to be here to witness the evolution. Feel free to tell me I'm wrong in the comments so I can laugh, and I'll see you guys on the next one.